Hello, and welcome to Let's Talk Clean Air, where we find out more about how clean air can affect the quality process for you and the workplace. I'm your host, Jacob Stewart, and in this episode, we're going to be discussing dust collection within the metal processing industry. And with me today is Camfil APC's John Ladwig. So, how are you doing today, John?
I'm doing well, and thanks for having me on board. Looking forward to putting this podcast together.
Absolutely, glad to have you here. Just to start things off, can you tell me a little bit more about who you are and what you do here at Camfil?
So I'm the metal industry uh, metal processing specialist. Sorry, that name's changed a few times, and I've been working at Camfil now for 8 years, and I've been in the industry of dust collection for over 20 years. Worked in the beginning as a engineering and designing systems, and then worked on it in an engineering consulting role, and then I went on to be in a contracting role where we purchased and installed, specific systems designed right to the customer's criteria. And then actually that's where I met Camfil, and in the later on process, I was able to get on board with Camfil to be a one of the specialists on the crew, and I'm still holding that role today.
So I guess we'll go ahead and just get right into the questions. For the first question, what are some of the main hazards in the metal processing industry?
So in the metal processing industry, we face there's quite a few hazards, but the primary ones, as you said, are the main ones, are fumes that are created by welding, plasma, laser cutting, arc gouging, anything that melts metal away to reshape it, and also dusts that are created, which are metal dusts that are created from surface blasting and thermal spray. These are processes that one creates dust and one uses dust often. So you're dealing in raw metals in a dust form, which can be a fire and explosion hazard. So in the fumes world, it's what's in the fumes that can be hazardous to your health, and in the metal dust world, it's again, things that can be flammable or have an explosive characteristic.
So, is an indoor environment more susceptible to pollution than an outdoor environment, would you say?
I would say yes, absolutely yes, and it's simply because you have four walls and a roof or wrapped around your environment. So the indoor environment, without any processing, your indoor environment will naturally be have more pollutants than your outdoor environment because you're going to use outdoor air to ventilate your indoor space, and the indoor space again contains what's inside of it. So there's varying kinds of dusts, etc., that are just natural. But then you add in processing, metal processing of any kind, whether it's one of the fume creators or one of the metal dust creators, or any other dust creating process, that's now contained in your building. So it naturally is within an envelope, and whether you ventilate or don't ventilate, you're going to likely, barring filtration and high volumes of ventilation, you're going to have a worse environment for dust inside than you do outside for dust and fumes.
So, I guess to kind of build off of that, would you say that indoor air pollution is more harmful than outdoor air pollution?
I would say, yeah, yeah. In the land of processing, fabrication and processing, indoor air is typically going to be more harmful than outdoor air, especially during the northern climate. I personally live in Minnesota, so any of us folks who live up north, we're just coming into it's November. We're heading into November now, and stores are starting to come closed because it's too cold outside. You got to keep your people comfortable, and as you start closing doors, it even gets worse. It's there's more ventilation required, more energy required to keep a space heated. So filtration and what we do for a living is regarded as a very appropriate way to save energy and keep your air clean.
So, what are the biggest threats to workers' health and safety that come from welding and other metal processes?
So focusing on welding a little bit, the fumes from welding and metal cutting often include manganese, iron oxide, zinc oxide. If you're working with a chromium type steel, or which is stainless steel, as an example of that, you can get hot hexchrome off of that in the fume. Those are forms of what you'll find in a fume cloud. And when you're working with a raw metal application, surface blasting and thermal spray, these clouds often, again, they're raw metal in a fine form. So it's they're literally metal dust. And because they're so finely divided solids, they often test to be explosive or flammable. So those are the big threats.
And so, what are some of the benefits of clean air for employees?
For employees, I mean, if you are working for somebody who maintains a clean environment, you're going to noticeably feel healthier because you're breathing cleaner air. And you're also going to notice, as an employer, you're going to notice less worker complaints. And worker complaints can range from, I don't feel well today, I've got headaches when I go home, or they're just people don't like to be dirty. I mean, the metal industry is a dirty industry, but when you're working in dirty air, it just compounds that level of uncleanliness, I guess you'd call it. So the primary benefits are, clean air makes you feel better in a workplace.
And so, you'd say, in addition to physical health, that it also improves workers' mental health as well?
Sure, sure. I mean, they go hand in hand. If you're feeling good about your work environment, you're going to feel good about your job. You're gonna, be happy to go to work every day. So your mental health is stronger, and you're going to be better at your job because of that. That really applies if an employee has worked elsewhere where they didn't have good air quality, and then they've gone to work somewhere else where someone does take care of the air quality. Then they have that contrast of knowing how it could be. Some of the newer people on the market probably just don't. They just won't work at a place that has bad air quality. Just period. They'll do a tour of the plant and walk on and never come back. Especially this day and age where we've got a lot more people to hire than we have jobs. We're just looking for people constantly.
So, what are some of the general types of cartridge dust and fume collection systems used to clean up these welding processes?
So the types of cartridge dust and fume. Let's see. That's kind of a loaded question. So really, there's two answers there, or two concepts. Fume collection systems, which I'll focus on that first. A system is truly a full blown system. You turn on a switch, it captures the smoke, conveys the smoke, contains it in a dust collector, and returns clean air. That's what I would refer to as a system. And along with that system, it gives you a good way to manage the dust or the waste stream. It gives you a good way to at the capture source. It's works well with with how the employee works with it, so it's not constantly pushed out of the way. It's ergonomically correct, I guess you'd say. So there's really that kind of falls right into what I want, the point I'm trying to make, which is there's in dust collection, there's a rule we call the 3 C's of dust collection. You need to capture the dust, convey the dust, and then contain it. So the fume collection system includes all those things. Examples of capturing the dust are, using source capture fume arms, source capture fume exhaust guns, welding guns that have the nozzle that sucks up the fume right at the gun. A backdraft hood, so when you're welding, the fumes are drawn away from you and sucked into the system. And in situations where you have bigger parts, you use canopy hoods because the parts are so big that the source capture methods don't work. And or you use enclosures in the case of like robots is a good example. Robotic welding and robotic plasma cutting, you put that in an enclosure and you draw a certain volume of air off of it, and you keep all the fumes stay in, they never come out. So the fumes are not getting into your factory. They're only in the enclosure where the robot is. Nobody's getting hurt, and that space is kept clean. And that heat and energy that's generated by the process is recirculated back into the facility. And then there's ambient systems where the parts you're building are so large that you can't really fit them. You can't do any of the other methods. So the welders can basically are allowed to go out there, go about their day welding on these large frames, and then you circulate the air in the facility and scrub the air clean in such a timely fashion that it maintains clean air in the space. That's another way of doing it. So that's your capturing methods. And then you've got conveying, and conveying the duct is simply done by properly sized ductwork. And that ductwork is sized such that it maintains conveying velocity, so the dusts are carried through the ductwork and don't settle out. And then those dusts arrive back at the dust collector, and the dust collector provides the containment piece. So at the dust collector, that's where we separate the dust from the air, and then using a cleaning system, we remove the particulate from the filters into the hoppers and into using the pulse cleaning, and then it drops it into a drum or a bin, and that's now contained. And now it's contained in a fashion where you can, easily manage it and remove it and take care of it. At the end of that, the containment piece is the cartridge dust collector. So I don't know, we'll probably dig into that a little bit more later, but that gives you a sense of what it takes to put a system together for a welding process.
So you've mentioned a little bit about particulate matter. Can you tell me more about the categories used to describe both dust and particulate matter? And can you list some examples of dust particle sizes?
This is an interesting nuance that's going on in the world today. A lot of people have heard of particulate matter, or PM1. PM1 is a particle size that viruses fall in, and we're all in. We've been faced with this pandemic and COVID, and wondering how do we keep minimize the viruses from getting around. A lot of people are using HEPA filters within their facilities and their offices and things like that to keep that air clean, so they minimize the exposure people have. So PM1 is a category that the World Health Organization has created. They've created a category of PM dusts, particle matter. They've got PM1, PM2.5, and PM10. Now that the number refers to the micron size or smaller of the dust. So to give you an example of what that means, in the dust world, a PM10 dust is 10 micron or smaller, and it's a fine dust or a pollen or mold, and that dust is capable of reaching into your respiratory ducts, typically managed by your natural ability. So it's not a overly large threat, but it could trigger allergies, asthmas, things like that. PM 2.5 dust is 2.5 micron or smaller dusts. Examples of this are products of combustion, asbestos dust, bacterias. These are all dusts that, when inhaled, they can penetrate into your lungs. So they get a little deeper into your breathing system, and they're harder to manage. They're going to trigger more responses. They're going to cause more reactions from the body. And then, of course, PM1, which is 1 micron or smaller dust. Good examples are soot and viruses. And these dusts or particles, when breathed in, not only do they go into the lungs, but they're absorbed into the alveoli, and the alveoli actually puts them right into your bloodstream. So now they're actually brought right in, and they're now spread throughout your body. It's a prime example of why viruses are such a big deal. They're absorbed right into your bloodstream. So the flus, the COVIDs, the things like this. And for the metal industry, the metal generated dust is that we worry about is hexchrome and cadmiums. Some of those dusts, those are IUM dusts, we refer to them as. Those get right into your bloodstream. They can cause cancers. They can cause all kinds of very serious reactions, especially over long-term exposures.
So why is it so important to know types of particulate by size?
If I'm going to focus this answer based on looking at it from a manufacturing standpoint, from a facility standpoint, you're going to look at the dust that's in your facility. You're going to do some studying. You're going to, you're going to get some environmental engineers to do some sampling. You're going to test some things, find out what's in your air and how much of what's in your air, and then from that you'll have a breakdown of, do I have a lot of large dust? Do I have a lot of PM10 dust in my air, or do I have a lot of PM1 dust in my air? And now that I know that, what is that? The environmental engineers can tell you what is it that's in those. What is the material? What is the metal? What is it made of? So you can get a really good sense of the specific pollutants that you're up against in your facility. And then knowing all of that, it helps to put together a proper risk management strategy to remove that out of the air in your facility and minimize it so you can minimize exposure for your employees.
So, what sort of damages can malfunctioning dust collection equipment cause, and what are some common signs of fume extraction equipment malfunction?
So based on the assumption that you have systems in place and you have a facility that operates well, and when all the systems are going well, it's a very clean environment. First thing you're going to notice when something is malfunctioning is you're going to start to see faster dust on surfaces. It's going to accumulate faster on surfaces. If you look across your facility, you're going to start to see visible fumes in the areas where you're probably having some of those malfunctions. Um, as that dust becomes an issue and accumulates faster, you can see malfunction in electronic equipments. A lot of equipment on the manufacturing floor today has circuit boards, et cetera. Welders, welding machines, not the human welder, but the welding machines got circuit boards in it. Robots are computer operated. Cranes have a brain in them to control their function, and there's many other examples. But they all have openings in their enclosures so that the heat developed can get out. Well, that lets dust get in. So you start to see equipment malfunctions popping up on sensitive equipment. And then, of course, the other one that's probably pretty quick to be noticed is employee complaints. Employees who are used to a clean environment are going to be some of the first people to say, "Hey, something's not right here. We gotta, I'm noticing when I go home, I've got some extra black stuff in my nose or whatever. I'm coughing a little more or whatever." They'll notice it right away because they're breathing it. The people who are on the floor in the area. So those are some of the things that, so basically damages and common signs that fume extraction is malfunctioning.
Right. So, when is a dust hazard analysis necessary, and how often should one test for explosiveness and flammability?
Well, a dust hazard analysis specifically stems from if you have a dust that has a explosiveness or flammability. So, based on OSHA's general duty clause, anybody who runs a facility that creates dust needs to test that dust and know what it is. One of the tests that we do with dust is explosivity testing. That testing is simply you gather a certain volume of that dust, you send it to a lab. That lab disperses it into the air, ignites it, and tries to get it to explode. They do that multiple times, and then they produce a result. And that result, the test results can come back and they can be non-explosive, which means you just have general dust, or they can be explosive. And if they are explosive, then they would typically give you a resulting KST value and a Pmax value that kind of helps define how explosive is that dust. Also with that, you'd want to know, is it organic dust or metal dust? So that all plays into this. But if you have an explosive dust or one that comes back positive with a positive test, then you need to head into NFPA 652, which is one of the chapters in the National Fire Protection Association manuals. And that explains how to put together a duct hazard analysis. And then you figure out, you dig into that. So now you've got your explosibility test as one of the first things you do. And then you figure out where is the dust coming from. It's a dive into, who, what, where, why about that dust. So that's when a dust hazard analysis is necessary. It's necessary when you get a dust that comes back with a positive explosivity result.
So, what are some ways to be proactive about weld fume control?
So weld fume control, I'm going to back up a little further on this. Instead of just saying we're in a facility that's already making it, I'm going to say that you're a manufacturer who's going to expand your facility or you're going to build a new facility. Well, some of the first things that people can do, and a lot of people overlook this, is you can work with your consumable provider to select the best welding wire and gases combination to still give you a quality weld, but produce the minimum quantity of fumes. Sometimes the people think that the biggest, hardest, fastest welding methods are the best methods. That's not necessarily true. You can accomplish the same thing with different combinations of gases and different combinations of weld wire and still end up with a quality weld. Sometimes you can't. Sometimes you got to do it a certain way, and that's it. That's your choice. But there are other times where you can dial it back and change those combinations and get less fumes out of the deal. So you have less fume to manage, or you've minimized it, let's say. The other thing is to look at your space in your facility as you begin to think about how am I going to manage the fumes generated by my welding department and by my plasma cutting department or my laser department, right, for cutting metals. You think about that as you're buying equipment, as you're doing it, so that it's in your forethought. So if I'm buying a laser or a plasma or a robotic beam profiler machine, okay, all of those you can buy with a dust collection system for them. So they come in an enclosure. You've got to pay some extra money, but the process comes, it's got its own enclosure that's been designed by the manufacturer. They'll often have a dust collector manufacturer that they've worked with, comes together, it's all engineered. That now you have no fumes from those processes. So they're all managed already. On the welding side, where you've got anywhere from a 10 to 15, 20 welders in a certain area, look at the airflow in your facility. And as you manage your space and manage your ventilation, make sure that your ventilation isn't coming from the welding area going out into your facility. You don't want to spread those fumes out. You want to contain those. So make sure your ventilation is going towards that. And whether that ventilation is an exhaust and supply system, or whether it's a filtration system, you want to draw the fumes towards where those welders are. So they're the only ones being exposed. That sounds a little bit, maybe harsh, but you're not expanding the exposure to other people and minimizing the exposure in your facility.
So, what are air quality goals and how important is it to implement them?
So air quality goals, it's a tricky because it's not just a goal that you make up. There are goals already out there, and so many companies follow OSHA. They want to meet the OSHA requirements for fume exposure in their facility, and OSHA has guidelines for all varying kinds of fumes. And you can test for those using an environmental engineer and doing air quality samples. And you can see if you're having a spike or not and make corrections. You meet the OSHA guidelines. That's your kind of your code minimum, I would say. But often we're seeing more and more with the larger manufacturers. Many of them are taking a next step. They're saying, okay, that's the minimum requirement, but we're going to go by the guidelines that are more stringent than there's guidelines put out by the ACGIH. They have recommended guidelines which are much more stringent. They're much more lower numbers. Again, they're providing a safety factor for their people and for their facility, so that they're not even coming close to the OSHA guidelines or the OSHA requirements. FYI, the ICGIH is the American Conference of Governmental Industrial Hygienists, and they put together all kinds of guidelines, all kinds of recommendations for how to do things, even how to lay out systems and things like that. It's a good source for industrial ventilation. So other things that we see in the world, these days is there's a lot of widespread communication, right? Everybody's communicating all day long. Everybody has a cell phone. The word spreads very fast in the world today. And so one of the things that you want to be very, very aware of is that. So if you've got a facility that is a dirty facility and it's cloudy and it's not healthy, and you're running into questionable OSHA compliance, you may find, the most of the time, and I don't know how to put this gently, but most of the time people are turned into OSHA because either your neighbor can see fumes coming out of your building and they don't like it, or they're seeing the result of your facility on their cars in their parking lot, or you've got employees who feel like they work there and they want to stay there, but they also want a good place to work and they're not feeling comfortable in that workplace. So they'll communicate to OSHA that there might be a problem here. So having air quality goals in the world today is a way to stay ahead of that. I guess was my whole point there.
Okay, so we've talked a lot about COVID-19, the whole pandemic. Has the pandemic changed the way that we go about dust collection, would you say?
I would say that the pandemic widened the awareness in the world of how air quality in general affects our health. Not only in places where there was a widespread pollution, and because of the pandemic and the shutdown and everybody being at home and all of that, now they can see again. There's places where they can now see the mountains that surround their cities. The haze that's over the city is gone, and nobody thought that was everybody just thought that was just a part of my day. So we learned that, hey, that's not a part of my day. If we treat the world differently, we can make that pollution go away. So there's that awareness and how that affects our health. And there's also, employers are focusing on providing the best air quality they can for their workers now, because it is such a forefront. It's right there in the forefront now. How are we managing minimizing the risk of COVID or the flu or any other virus type of thing that's out there. So it brought the awareness of air quality to the forefront for people and employers both. So now that, and I think that's the primary thing. So how does that play into dust collection? Well, that's what dust collection is. We clean the air. Schools, gyms, many other facilities, office spaces, they've been buying HEPA filtration machines by the truckload so they can put them in their space. It's not to stop COVID from being transferred from person to person, but it's to take down the overall volume of viruses in the space so that your likelihood of being exposed gets reduced and the space gets cleaned when you're not there. So classroom of people, the people go away, the space gets cleaned before the next group of students comes in, that kind of thing. Or just a steady in an office space, the air is cleaned all day long, minimizing the particulate matter that you're exposed to. So that's filtration, that's dust collection, just a different form. And at Camfil, we do all of those things. So we see it all from the offices to the factories.
So, what advice would you have for somebody regarding selecting proper filtration?
The advice I have for people out there who are looking at proper filtration is first get to know your dust. Understand what it is that's causing your dust to occur. Start to understand how much dust you're going to be dealing with. If it's a source issue, like a process like plasma cutting or thermal spray or blasting, surface blasting of metal. Those are things, that's what I'm talking about there. Get to know what's causing your dust source, how much is there, what's in it. Start learning, research what's in the dust. If you already have dust in your facility, do some research to have an environmental engineer come in, do some testing so you can get a sense of how much of what kind of dust do I have. If there's enough dust that you can get some samples run to a lab to check for explosivity, do that. In that process, you're going to get back a breakdown of how much of what size dust you have. And then with all of that in your hands, start talking to a reputable dust collection manufacturer. Obviously Camfil Air Pollution Control is one of those sources. We pride ourselves on asking those questions, understanding your sources and your needs for your application. And then we can physically look at, a dust collector is more than just the box. I don't care what color that box is, green, blue, gray. It's what's in that box. The filters are the heart of that dust collector. And depending on what your dust is and what you're trying to achieve, proper filtration comes from putting the right volume, using the right volume air to capture that dust, sizing the collector right to handle that dust on the filters, and picking out proper filters to best capture the dust and then release the dust so it can be pulsed off into the barrel and be contained so that you can properly manage it for the waste stream. So that's my advice to somebody who's starting to look at this concept.
All right. Well, thank you, John, for stopping by. If you'd like to find out more about this and other topics, simply follow the links in the show notes, which you'll find in the description of this podcast. They include links, contact details, and anything else you might need to get more information. This podcast was produced by Camfil. the world leader in the production and development of air filters and clean air solutions. You can find out more at camfil.com. Be sure to join us for our next episode and be sure to subscribe to get notifications for future episodes. Until then, I'm your host, Jacob Stewart, and this has been Let's Talk Clean Air. Thank you for listening.